maximum and minimum values. I have already told you about this. We'll just write down few notes. Values of a function in a closed interval. Okay, if they say find the maximum and minimum value from A to B, okay, then you have to do find all the critical points of f in the interval, that is find points where f dash x is 0 or not differentiable. Take the endpoints of the interval just a second. Calculate f of x at all these points. Okay, if you do three things, you can get the answer to this thing, which is find the maximum and minimum value in a given interval. Okay, note it down. Then try this question. Find absolute maximum and minimum. Absolute maximum and minimum means global maximum and minimum value of the function of x equals to 2x cube minus 15x square plus 36x plus 1 on the interval 1 to 5. Okay, apply this rule and try to solve it. I'll give you a few minutes. All right, Taha. Let's wait for a few other answers. All right, Zara. Rishita, did you solve it?
No, sir.
Okay. First step is to find critical points. So we'll find f dash x, which will be 6x square minus 30x plus 36. We'll put this as 0. This implies 6 taken out. X square minus 5x plus 6 equals to 0. 6 times this is x minus 2, x minus 3 equals to 0. So x is 2 and 3. So with this, we'll take the endpoints of the intervals also. Okay. So the final values of x we have is 2, 3, 1, and 5. Now all you have to do is find f of 1, f of 2, f of 3, f of 5. Whichever is maximum is the maximum value, whichever is the minimum is the minimum value. All right, Ishita?
Yes, sir.
Okay. One last thing, monotonicity. Anyone knows what this is? What do you mean if your life becomes monotonous?
Uh,
What does
Very
it?
bland.
Very bland. Yes, that is a synonym, but what if you have to elaborate what it means?
Nothing new is going on.
Yes, it's the same thing again and again, again and again, right? We are repeating the same thing. It's the same journey, right?
Yes, sir.
So in graphs also, monotonous means if a function is just increasing in every point of the value, okay, not even constant, it's just increasing from start to end in its entire domain, then we say it is a monotonous function, okay, and it's increasing. Same thing with decreasing. If it is decreasing in its entire domain, we say it's monotonous and decreasing, okay.
Yes, sir.
Yes, everyone got it.
Yes, sir.
Yes,
Okay.
sir.
So this chapter is officially over. Any doubts you have, just go through it. 5 minutes I'll give you. Any doubts you have, just check it out. Anything you did not understand, otherwise we'll start a new chapter. Okay. Okay, I guess no doubts. Okay, next chapter is vector. You all know about what is vector?
Yes, sir.
Okay, what is it?
It's something that has magnitude and direction.
Something that has magnitude and direction. Okay, very good. That is the definition of vector. But one thing you are missing is it also obeys vector addition law, right? If you know in physics, is current a vector?
Mm. Yes, sir.
Yes, right. Everyone, Zara, Taha,
Yes.
yes, current is a vector. Okay, so let me give you a question. You have to calculate I. How much is it? Let me join the circuit. How much is the I?
It is just 9 ampere.
9 ampere. Okay. Any other answers? Rishita, Taha,
Sir, 9.
9. Okay. Rishita,
9.
9. But they are making 90-degree angle. Okay. So if a vector is like this, 3 and 4, what is the resultant value? There are two vectors, AP and AC. We have to find the resultant vector. Anybody knows?
So do we add them or
Do we
find the
add them?
magnitude?
Yes, find the magnitude. AP vector plus AC vector. You have to tell me the magnitude of AB plus AC. Angle is 90-degree between them.
A cross B?
A cross B. That is the answer. You guys are all from science background, right? As per I know. Yes.
Yes, sir.
You guys have finished electrostatics of class 12. Yes.
Yes, sir.
Okay. Current electricity,
Yes.
magnetism. No, magnetism is not completed. Okay. Then you are in a very bad state. Okay. Let me tell you, you should focus on physics at least a little bit. If you don't know how to add vectors, it's a very, I will teach you. That is a different thing. But you should know. Okay. If vectors are making 90-degree, then the formula, there is a formula of vector addition, right? But you should not even need the formula. But that is fine. And current is not a vector. Okay, if that was a vector, this angle would have mattered, right? Even though current has a direction. Okay, and what is the direction of current? from positive to negative, is it so? Or negative to positive?
Positive to negative.
Positive to negative. So current has a direction and a magnitude, but it does not obey vector addition law. And what is vector addition law? Anyone knows?
We can add the vectors which are in the same direction.
Okay, so we cannot add vectors which are not in the same direction. Is that so?
I don't know.
You don't know. Okay. Taha, Sarah,
No, sir.
There's
you
like
don't know.
parallelogram law and Rolle's laws.
Yes. Can you repeat?
There's a parallelogram law and then the triangle law.
Yes, absolutely correct, Sarah. Very good. There is a parallelogram law and triangle law, which all vectors must follow. It's a like, what do we say? Holy book for vectors. Okay. If they do not follow that, they are not vectors. And current does not follow that. Even pressure does not follow that. That is why even pressure is not a vector, even though that has a direction and magnitude. Okay.
Yes, sir.
Okay, sir.
All right. This is class 9 definition, which you said that anything has a magnitude and direction is vector. Third thing is it should follow vector addition law. Okay. Understood, everyone?
Yes, sir.
Yes,
So please write it down. A quantity which has both magnitude and direction and follows vector addition law is known as vector. Done, everyone?
Yes.
A vector looks like this, right? This is called initial point. This is known as terminal point. Okay. In physics, you must have known this as head and tail, right? But it in maths will generally speak this as terminal point and initial point. This length from A to B is its magnitude. Okay. Also, this is written as AB mod. Yes. Yes or no?
Yes.
Yes, sir.
The initial point is always written first and the terminal point is written last, the later. AB means it is starting from A going towards B. Okay? All right. Distance is a scalar or a vector.
Scalar.
What is the vector form of distance?
Displacement.
Displacement.
So can you go up 1 second?
Okay.
Yes, sir.
All right. Is force a vector? Okay. So much time.
Yes, sir.
Force is a okay. Force is a vector, Rishita.
Yes, sir.
Okay, Zara. Taha, what about you? Yes, force is a vector. Okay. Acceleration.
Yes.
Vector.
Okay. Vector. Mass.
Scalar.
Okay. Zara.
Scalar.
Scalar. What about weight?
Vector.
Rishita, Zara.
Vector.
Okay. Why is vector? Why is weight a vector?
Because it has gravitational direction and force.
Gravitational direction. Okay. It is the gravitational force, and if force is a vector, then it must be a vector, right? Because it is a force, nothing much. So like we have just named it, right? But it is a force. Yes.
Yes,
Yes,
sir.
sir.
Okay. So hopefully basics are clear. Types of vector. I'll name them. You'll tell me what they are. Zero vector or null vector. What is null vector or void vector? No magnitude or direction. Okay. A vector which has zero magnitude is known as null vector. Okay. It can have any direction. Okay. And it is written as zero vector. We can also say its initial point and terminal point coincide. Unit vector. What are unit vectors?
Magnitude is 1 unit.
Very good. A vector which has magnitude as unity. Okay. And remember, unit vector is the most important vector in mathematics, also in physics. Okay. Everything will revolve around this unit vector. And one other vector, which is the position vector, which we will learn in later stage. Unit vector, why it's very important? Please write it down. It is used to show direction. Okay. Remember, whenever we need to show a direction, okay, that it is in the AB direction or BC direction or some direction, then it will be used. Okay. What will be used? Unit vector. Now remember, when I say direction, don't think north, west, south, east. Direction means any direction we want to show. Okay. Arbitrary direction. Got it?
Yes, sir.
Yes, sir.
And how do we use this? How do we find this? If AB is a vector, okay, then unit vector is noted as AB cap. Ever seen this cap?
Yes, sir.
Yes, sir.
Where have you seen this?
I cap, J cap, K cap,
Yes.
direction, X, Y, Z.
And what is I cap, J cap, K cap?
I is
Axis.
X.
Axis.
Uh, X, Y, and Z axis.
X, Y, and Z axis. Actually, I get the feeling that you know this, but better way to say is the unit vectors we use in the direction of x-axis, y-axis, and z-axis. Okay, if we have to show x-axis direction, then we use I cap, right?
Yes.
Yes or no?
Yes, sir.
So whenever we have to use direction, a unit vector is used. And written is like this. And how do we find unit vector? Always divide the vector with its
By
magnitude. Yes. Okay. And you get a unit vector. Okay.
Yes.
Please remember this thing. It will be very useful in a lot of questions. Whenever somebody asks you to find a vector in a specific direction, remember to use unit vector. Okay. Note it down. Co-initial vector. Can anyone take a guess what it will be?
Starting from the same point.
Yes. Vectors having same initial point are called co-initial vectors. Please note it down. Done?
Yes, sir.
Okay. Equal vectors. What are equal vectors?
Vectors with same magnitude and direction.
Yes. Yes. Same direction and magnitude has two vectors, then they are called equal vectors. Okay. Note it down. Negative of a vector or negative vector. Two vectors having same magnitude but opposite direction. Okay, if this is AB vector, then this will be minus AB vector. Okay, note it down. Okay, done.
Yes, sir.
All right. Okay, question says which vectors are collinear, equal, and coinitial. Okay, did I tell you about collinear vectors? No. Write down another one, seventh one, collinear vectors. Okay, then we'll do this question. Collinear vectors. Two vectors having same direction or parallel. Two parallel vectors are collinear. Okay, irrespective of their magnitude. In fact, the most accurate definition is two vectors parallel to the same line, then they are collinear vectors. Okay, Okay, to this question. All right, Zara. See, B, C, D are co-initial, right?
Yes, sir.
Equal, we can see C and D are equal. Sorry, C and A are equal. Yes. And collinear, which are collinear? D also, remember. In collinear, I told you if they are parallel to the same line. Okay. So even though C and D has opposite direction, but they are parallel to the same line. Okay.
Okay, sir.
So even though their magnitude and direction be different, but remember if two vectors, if a line is like this, one vector is like this, another is like this, if they are parallel to the same line, then they are collinear. Okay. Yes.
Yes, sir.
All right. Okay, remember, whenever you have to add vectors, one vector should be kept, like tail of one vector should be kept as the head of another vector. Okay, then only we can add two vectors. So what does triangle law say? Triangle law says simply, if you add AB and BC vector, okay, AB vector plus BC vector, what you will get is AC vector. Okay, if two sides of a triangle represent vectors in the same direction, then their sum resultant vector is represented by third side in opposite direction. AB is like this, okay, moving from A to B, this direction. BC is this direction, so same direction, anti-clockwise, two sides of the triangle. Third side represent the resultant vector, their sum in the opposite direction. Okay, if they are moving anti-clockwise, they should move clockwise. Okay, yes or no?
Yes, sir.
Yes, sir.
All right, note it down. Done, everyone?
Yes, sir.
Who can tell me what will be the value of AB plus BC plus CA here? Think about this. Okay, let me give you the values here also. This is 2, 3, and 1. You can take the angles also. This is suppose 30. Let's make it 60. No, it does not look like 90. 30, 30, and take this as 120. Okay.
So will it be equal to 0?
Yes, very good. Absolutely correct. Okay, you can take this vector, okay, which is AB and BC. Okay, they are in the same direction. Okay, and two sides of the triangle. That means I can write AB plus BC will be equals to third side in the opposite direction. That means in this direction, okay, which is AC. Now we can see that AC is negative of CA. So if you add AC plus CA, it will be 0. Yes or no?
Yes, sir.
All right. So this kind of questions you should not take much time, as you already know about practice. All right. If we have A vector like this and B vector like this, if you extend it backwards in the same direction, like opposite direction of B and same magnitude, then this thing here, this becomes A vector minus B vector, right? This direction and this direction. So third side opposite direction is the A plus minus B. So A minus B. Is it understood or do I need to explain further?
No, sir.
So this is how we subtract vectors. Okay. Parallelogram law. Of vector addition. Sorry. It says if we have two vectors A and B represented by two adjacent sides of a parallelogram in magnitude and direction. Then their sum A plus B is represented by the diagonal. Okay. Done everyone? Yes or no?
Yes.
Okay. Multiplication of a scalar or of a vector with a scalar. If we multiply a vector A with the scalar lambda, then its direction does not change, but magnitude becomes lambda times A. Okay, very simple. As you are multiplying with a scalar, if this was vector A and you multiply with a lambda, it becomes lambda A, and it will be like this. Magnitude will change. Okay, direction remains same. Okay.
Yes, sir.
Okay, note it down. Done, everyone?
Yes, sir.
Components of a vector. Okay, here first listen. Okay, then on your right, if we have 3 points 1 comma 0 comma 0, 0 comma 1 comma 0, and 0 comma 0 comma 1. Okay, can anyone tell me if I write OA vector magnitude, how much will it be? Magnitude of OA.
Um,
Sorry.
√2.
Okay, the location of A is 1 comma 0 comma 0. So if you walk from O to A, you will move √2 distance.
Will it be I cap?
Yes, this distance is 1, right? Magnitude is 1. If you start from O, walk towards A, how much will you move? 1 unit.
Sorry, sir. I was looking at
Yes,
C and A.
yes. But to A, it will be 1. Okay. And this vector OA vector is known as I cap. Okay, vector having direction of x-axis but magnitude of 1. Same with B vector, OB vector. Magnitude is 1 and this is known as J cap. And OC vector, magnitude is 1, it is known as K vector, K cap. Okay. Yes.
Yes, sir.
Okay, if I take another vector, okay, now I need some visualization from you. Okay, imagine this is coming outside of the screen. Okay, this is O, let's say this is A. This coordinate of A is x comma y comma z. Remember, A is the coordinate of x. Coordinate of A is x comma y comma z. That means to reach A, you have to walk x units in the distance of x-axis, y units in the distance in the direction of y-axis, and z units in the direction of z-axis. Okay. Yes.
Yes, sir.
Then then if this is a point P and this is Q and this is R, can I write OP will be x I cap and OQ will be y j cap and OR will it be z k cap? Yes or no? Okay.
Yes, sir.
So if I write like this, OA vector will it be x I cap plus y j cap plus z k cap? Does anyone has any issue? To reach A, I have to walk x units in the direction of x-axis, y units in the direction of y-axis, z units in the direction of z-axis. Then I will reach A, and that is OA vector. Okay. Yes or no?
Yes, sir.
This is known as components of vector. Okay. That means if you have to find OA magnitude, then we can just square it and take root using Pythagoras. Okay. All right. If a vector is in component form, then you can find magnitude like this. Okay, everyone.
Yes, sir.
Yes, sir.
Okay. Noted. Shall we move on? Addition of vectors in component form. Okay. If we have two vectors, A, which is A1 I cap plus A2 j cap plus A3 k cap, and B vector, which is B1 I cap plus B2 j cap plus B3 k cap, then A vector plus B vector would be simply A1 plus B1 I cap plus A2 plus B2 j cap plus A3 plus B3 k cap. Okay, just add the I components and you will be done. J components and k components. Okay, same with A minus B. It will be A1 minus B1 I cap plus A2 minus B2 j cap plus A3 minus B3 k cap. Okay, multiplication by a scalar. If there is a vector A1 I cap plus A2 j cap plus A3 k cap and a scalar lambda, and you find lambda times a vector, it will simply be lambda A1 I cap plus lambda A2 j cap plus lambda A3 k cap. Multiply the scalar to all of the terms, you will get the answer. I believe you already know all this. Yes? Yes or no, everyone?
Yes, sir.
All right. Note it down. Okay. And write a third point in this. If A vector is equal to B vector, then A1 must be equal to B1, A2 must be equal to B2, and A3 must be equal to B3. Okay, the components must be equal as is. Done, everyone? Yes or no? These are the basics of vectors. Vishita, Taha, Zara, any doubts?
No, sir.
Okay. Find x, y, z. A vector and B vector are equal. A vector is xi cap plus 2j cap plus zk cap. B vector is 2i cap plus 5j cap plus k cap. This is not very difficult question. Rishita, what is the answer?
Sir, X is 2, Y is 2, and Z is 1.
Right, very good. Okay. Find a unit vector in the direction of A vector as 2i cap plus 3j cap plus k cap. Okay. You have to find a unit vector in the direction of the. Just remember how we find unit vector. Okay. See, the only way
Yes,
to
sir.
find unit vectors is like this. Zara, yes? And magnitude of A, if we have to find, we have to do root 2 square plus 3 square plus 1 square. Okay. So it will be 4 plus 13, 14, 1 upon root 14 times 2I cap plus 3j cap plus k cap. Okay. Yes or no?
Yes, sir.
All right. So this is all for today's class, guys. Take care. We'll do lots of questions in the next class. Okay, do not skip it. In fact, is a very easy chapter. We'll complete it very soon. Okay.
Okay, thank you.
Sorry, Sarah, what did you say?
I said, sir, thank you. Okay.
Okay, okay, no problem.